Yesterday, when we did the experiment with the Schmoo, I said that it was not possible that it could sink current. Well, that's not quite true. Okay, here's the setup. There's my Schmoo. Normally, we'd set it up for sourcing by plugging in the red lead on the positive, black lead on the negative. Let's say it's connected to something that we want to source current to. That's the normal setup. But here's a twist. If we move this down the amp measure and we add a jumper cable from the negative to here, the current is going to come through here, through there, and down to whatever it is that we're measuring and sourcing. Add another jumper cable here, and we can measure voltage or current on the meter side of it while sourcing on the source side. And here's the other end of the connection. It's a little simple battery holder. Now I've modified it so that it only holds one battery. That keeps the voltage down to between 1.3 and 1.5 volts for a fully charged battery. This one happens to be one of those rechargeable long life batteries. There's a switch on the back, turns the battery on and off, and it's connected up to the source measuring unit. So here's the deal. This thing's got a multimeter in it. It measures amps. How does it do that? It's got a shunt inside that will handle up to 3 amps. That means that this will pass current through and measure with the measurement on an ammeter of up to 3 amps. That's called sinking current. What we're going to do is hook up the little battery just to show how this works. Red to red, black to black. We're going to go on auto scale and measure current. I'm going to switch the battery on. And off again. We're on DC. There we go. So it's 2.6 amps. That current is being absorbed by the shunt and cooled by the fan inside the unit. So we're sinking current right now. But how do we get this so that we're only sinking, let's say, 20 milliamps? Okay, I'm back to the special setup, and I'm measuring the voltage of the battery, about 1.33 volts. I've set up constant voltage on the S2 scale, which is the one that goes up to 3 amps of current. Constant voltage. Let's see what happens when I push the output button. And I'm going to switch it to the amp scale. What we're measuring is the net current through the system. So I'm sourcing 1.334 volts here, and that's overcoming the voltage that the battery is currently supplying. So if I change my voltage, let's say I raise it, now I'm moved into actually sourcing current, and if I lower it, I'm sinking current. How low can we go? If I'm set on the lowest milliamp measure scale, it'll go up to about 9 milliamps. If I switch it up to the next lowest, there's a tenfold change in it. So now it's sinking 20 milliamps. If I want to see how much farther I can go down, just drop the voltage, and it bottoms out at about 22.8 milliamps sink current. If I go up, then we're sinking less and less and less. When it crosses over 0, we're sourcing current, and there's virtually only limit of the ranges on the instrument itself for what it can source. So what we've done here is we've taken advantage of the sourcing side to buck the voltage of a small battery source. Now, between the battery and the instrument, you could put any sort of device that you want to test. Using the programming functions, you can set up a ramp or a scan that will raise the voltage and lower the voltage. Keep in mind that it only goes down to 0 on constant voltage, But what we want to be able to do is to maintain a voltage somewhere around 1.3 volts. Now you can't do that directly with the instrument because all of the ramps and scans start at 0. But you can do it in programming, and I'll get to that in a later experiment. Well, I don't think Keysight needs to worry about this technique taking business away from their regular source measurement units. But it is nice to know that a relatively inexpensive combined device, multimeter and power supply, can be used by the avid hobbyist or small business to actually do much of what can be done by a $4,000 plus source measurement unit. Thanks for watching, and please, a thumbs up. Bye.